more productive could your teams be with an enterprise AI assistant? At Effectual, we've seen productivity gains across business units for both our own teams and our clients. We can integrate our internal chatbots with our private internal data using RAG, or Retrieval Augmented Generation. RAG supplements the data available to answer your users' questions based on. We can rely on the state-of-the-art foundational models without any pre-training or retraining while getting the context of your private data. All of the data stays inside of your private AWS account and is never used by the model providers. This data could be from SharePoint, Confluence, S3, or a variety of other data storage locations. It could be documents, images, SQL data, or a variety of other data formats. At Effectual, we recognize that no two use cases are identical, and our clients need to move quickly with AI to keep up with their competitors. To facilitate the quick deployment of AI applications, we've created the Generative AI Accelerator. This is a set of pre-built production quality components across the RAG stack. For example, we have components to load documents from Confluence and S3, to store and retrieve them from OpenSearch or Postgres, and to manage chat history in DynamoDB or RDS. Today, I'm going to share the architecture diagram in a demo that leverages this accelerator. This demo application is for an internal analyst persona at a financial institution who wants to quickly access information from earnings calls transcripts through a conversational interface. Though this information is publicly available, it's been loaded as if it were private. This demo includes the earnings calls transcripts for Bank of America and JP Chase for each quarter in 2023 and Q1 of 2024. Let's take a look at the architecture diagram. At the top, we have the user interface. Users log in through Amazon Cognito, which is connected to our corporate Active Directory, and all of our users will sign on with their single sign-on credentials. The user interface is a statically hosted S3 site written in React TypeScript. We have an API gateway REST API, which uses Lambda to interact with chats and user feedback that's all stored in DynamoDB. Next, we have document ingestion. For this demo, we've loaded publicly available data as if it were private. In this case, that's the earnings calls transcripts for Bank of America and JP Chase for each quarter in 2023 and Q1 of 2024. The transcripts are stored as PDF documents in a private S3 bucket. In a Fargate task, we extract the PDF document into document chunks using Amazon TextRact. Each chunk is just a small subset of text from the original document. We generate the embeddings vectors for each document chunk using Amazon Titan's embeddings model via AWS Bedrock. The embeddings vector is a numeric representation of the text itself that we'll use to find similar documents later. The last step in the Fargate task is to generate the metadata for each document chunk. In this application, the metadata consists of the institution, the year, the quarter, the page, and the paragraph number, and a link back to the original source document. All of this information, the document chunks, the embeddings vectors, and the metadata are written to OpenSearch. Next, we have the API Gateway WebSocket API. This allows users to see responses as if they were being typed rather than in one big block of text. The user's question is sent in via the API. To start, we generate a self-query based on the question to come up with our metadata filters. For example, if the question asks about a specific quarter, let's say quarter 2, our metadata filter will limit the search to document chunks that have Q2 in their metadata. Next, we generate the embeddings vector for the question the same way we generated them for our documents using AWS Bedrock. We use the metadata filter and the embeddings vector to get the relevant documents from OpenSearch. In this example, we're using KNN, or the K nearest neighbors, to get the 10 most similar document chunks that match our metadata filters from OpenSearch. To generate the response to the question, we're reaching out to Claude 3 Sonnet via AWS Bedrock. In this example, we send the user query, any existing chat history, the relevant text from the documents, and their associated metadata to the Claude 3 Sonnet model. Claude sends back the answer to the question based on those relevant documents and the citations that link back to the original source documents so that users can easily validate the answers. The response is streamed back to the user via the API Gateway WebSocket API. Lastly, we update the chat history in DynamoDB to include the latest response. To get started, we'll sign in with SSO. These are our corporate credentials that we would use to authenticate to any other enterprise application. On the left, we have the chat history for the currently authenticated user, as well as some other standard operations. Our first question is about a single quarter and a single institution. We're going to ask, in their Q4 earnings call, did JP Morgan Chase comment on stock buybacks? You'll notice we get this live feedback from the application, telling us which step it's currently on in the RAG process. As the answer starts to come back, we'll get inline citations indicating exactly which source material was used in this response. At the bottom, we have an itemized list of those citations indicating the page and paragraph number for each one. Let's take a look at that earnings call transcript. The first citation comes from pages 4 and 5 and references the plan to maintain a modest pace of stock buybacks, as well as the SEB being low and volatile. These are two pieces of information that were in our answer. The next citation comes from page 7. Here we see Jeremy Barnum again, the CFO, responding to an analyst question. He mentions that they have a lot of flexibility to adjust the stock buyback pace whenever they want. You'll notice here in the last sentence of his answer, he doesn't actually say flexibility to adjust the buyback pace, rather he just says that. But back in our application, you'll see the chatbot was able to fill in that extra information for us and tell us that he was talking about adjusting the buyback pace. Our second question asks about both institutions and leverages multimodal capabilities. This means that in our question, we will provide both text and an image. Here we're asking, how are the institutions affected by COVID based on this graph in the earnings calls transcripts? The chatbot is able to tell us that this is stock prices from 2020 to 2024 and point out that both experienced a significant decline in early 2020. We also get some additional commentary from the earnings calls transcripts that we'd already previously ingested. Let's ask a follow-up question about the current stock prices. Here, we're leveraging what we call agents or tools to reach out to another system to get extra information. In this case, we're leveraging the Polygon last quote tool, which just gets the latest price for a stock. In other applications or production systems, this could be any internal or external tool with public or private data that you want your chatbot to be able to send information to, receive information from, or even perform updates in. For example, sending an email or updating a dashboard. Our third and final question asks about Bank of America's sentiment towards AI. You'll notice we didn't specifically have to spell out Bank of America, but rather we could use a common abbreviation, BOA. Our chatbot still understands that we meant Bank of America and will answer the question accordingly. Throughout the answer, we get our inline citations indicating where this material came from. And at the bottom, you'll notice our sources are not limited to a single quarter. And that's because we didn't limit our question to a single quarter, so we're going to get back a variety of sources. As a follow-up question, let's ask about JPMC. You'll notice we did not have to specifically ask about JPMC's approach to AI, but rather we could just say, what about JPMC? And this is because, again, the chatbot can contextualize that question and understand that we're still asking about AI. Lastly, we're going to provide some user feedback. Here we'll click the thumbs up and say that this was a good response. In this example, admin users can simply view all of the user feedback that's been provided in the application. In a production system, this information could be used to retrain or fine-tune the model, or even customize each individual user's experience based on their preferences.